So here are some examples. So here we want to determine the type of each differential equation. We want to know whether it's unlimited, limited, logistic, or none. So something that I would just recommend is everything that we've wrote down from this table. I don't know where the table is, right here. So everything here is what you might want to be looking at. You mainly want to be able to look at this part. So kind of try to identify or kind of match it up to these guys. And then after we figure out what the differential equation is, we don't need to solve it because we already know what the solutions are. So we just have to look at the solutions and then just go ahead and just match everything with what we have. So so let's go ahead and start. So in this problem, we just want to determine the type of each differential equation. So we don't want to solve them. We just want to tell what is what. So part A says y prime is equal to 0.02 times y. So this looks a lot like an unlimited one. So this looks like unlimited. Because if you look at the first on our little chart, this looks a lot like y prime equals ay, okay, which is actually unlimited, okay? Now, what about part B? So part B says y prime equals y, 6 minus y. So you can kind of see that you have a y on the outside and a y on the inside. So this is either going to be logistic or limited. So if we go back up into our little chart, you can see that the only one that has a y is the logistic. The limited doesn't have a y, okay? So that's kind of how you can differentiate between the two. So in this case, because there was a y in the differential equation, which was outside, this one would be considered logistic, okay? Now, what about part C? A y squared. So this kind of looks either like limited or logistic, but the fact that there's a y squared on the outside doesn't match up with any of them. So actually this one's none. It doesn't match with any of them. And then finally, the last one, you have 4,500 times 1 minus y. This looks like either logistic, so this logistic or limited, but the fact that there's no y on the outside makes it limited. Okay. All right, so sometimes you might have to factor a couple of things, like we'll do in the next problem. So here it's really easy to just figure out which one is limited, unlimited, or logistic. You just kind of have to look at the differential equation. Okay, so now let's go ahead and find the solution of these y value of y of t by recognizing each differential equation as unlimited, limited, or logistic, and then we're going to find its constants if we need to. Okay, so the first one says y prime equals negative y, and we have an initial condition of y of 0 equals 100. So initially we have 100 of whatever this is. So the first thing that I kind of notice is that this looks a lot like an unlimited problem. Okay, kind of like a y prime equals ay. So something that to kind of note is that if you look at the value of a, so if we kind of were to like look at this, we can see that the value of a is equal to negative 1, because that's the number that's right in front of it. So the solution to this, because we want to find the solution y of t, is just going to be y equals c e to the at, because that's what we solved, okay? All we got to figure out is what a is. A is just going to be negative 1, so y equals c e to the negative 1t, so it's just negative t. Now we need to figure out the constants, okay? So we're going to use this initial condition to figure it out. So we're going to have y of 0 is equal to c e to the negative 0. Y of 0 just gives me 100 equals c, okay? And this kind of makes sense because we know this is telling us that initially there's 100 people, or we can say people in here, in this environment. So, or maybe we're investing $100, I don't know. So let's plug it in. So my differential equation is going to be y equals 100 e to the negative t. Okay, so that's my solution to my differential equation. Let's do part B. So for part B, we have y prime is equal to 0.05 times 0.25 minus y, and then with an initial condition of 0, y of 0 equals 0. So you can look at this and you can see that there's no y on the outside, so this must be a limited one. We also have an initial condition at 0, which kind of gives it away as well. So let's go ahead and solve it. So just a couple things. You can kind of just say kind of model it with the differential equation. This is just a m minus y. Okay, so you can kind of just model it that way. So you can kind of see that your a value is going to be equal to 0.05 and your m value is going to be equal to 0.25 just by looking at these by inspection. This is your a, this is your m. So now time for the solution. So let's go ahead and figure out what the solution is going to be. So my solution for a limited growth problem is going to be y is equal to m1 minus e to the negative at. Now let's plug everything in. So y is equal to 0.25, 1 minus e to the negative 0.05 t. Okay. Now in this case, we don't need to find out what c is because there's no c. So this is going to be my solution. Okay. Of course, if you want to figure out, you can just put y of 0 equals 0, but we've done that already. Okay, so that's part B. Here we have part C. Y prime is equal to 80 minus 2y. Okay, so if you kind of take a look at it, it doesn't look like anything. But you might have an idea that it might look a lot like a limited one. So you might have to do a little bit of algebra. So you have y prime is equal to, one thing that we can do is factor out a 2. So we have 2, and then we are left with 40 minus y. Now the reason why I decided to factor out a 2 was because notice that if I look at all of my logistic and limited growth problems, I can see that you only have a y with a coefficient of 1. So you have a 1 in front of the y. So what I thought was that if I factor out that 2, you'll be able to have the y by itself. And then when you do, you can kind of clearly see that this is going to be a limited problem. So, so this is limited. So my differential equation of this is going to be y prime is equal to m, oops, that's wrong, a m minus y. Okay, here you can see that a is going to be equal to 2 and m is going to be equal to 40. Okay, so now let's go ahead and solve for the solution. So the solution in this case is going to be y is equal to m1 minus e to the negative at, and then just plug everything in there. So m is 40, 1 minus e to the negative 2t. Okay, so that's my solution. And now let's go to the monster one, okay, which is the logistic regression. I'm sorry, logistic model. Okay, so in this case, why is this logistic? Well, you have a y on the outside and a y on the inside, so therefore it makes it logistic. So this guy's logistic. Okay, so let me go ahead and write down the differential equation with the logistic. So you have y prime is equal to a y m minus y. Okay, you can clearly see that a is going to be 0.25, and then your m value is going to be equal to 0.5. Okay, so these are kind of like the values. So then the solution to this is just going to be equal y equals m over 1 plus c e to the negative a mt. Okay, so let me plug everything in there. So m is equal to 0.5 divided by 1 plus c e to the negative a, which is 0.25, m, which is equal to 0.5, and then t. So if I multiply that out, you get y is equal to 0.5 over 1 plus c e. When I multiply this guy out, I'm going to get negative 0.125 t. Okay. All right, so that's almost my answer because now what I need to figure out is what is going to be this value of c. Okay, because I still don't know what c is. Well, something that they've given me is the initial condition. Okay, we know that y of 0 is equal to 0.1. Okay, so y of 0 is going to be equal to, I'm going to plug in 0 into the t. So I'm going to plug in 0 there. This guy is just equal to 0.1 is equal to 0.5 over 1 plus c. E to the 0 is just going to be 1. Okay, so you just have a 1 there. So now what I'm going to do, you can kind of think about it this way. Let's put this over 1. You can cross multiply. So you're going to have 0.1 times 1 plus c is equal to 0.5. Okay, I'm going to divide by 0.1. So you're going to have 1 plus c is equal to 5. Subtract by 1, c is equal to 4. So that means that my differential equation, or I'm sorry, the solution is going to be 0.5 over 1 plus 4 e to the negative 0.125 times t. Okay, so one of the challenges about these problems is that, especially the logistic, is that you might have to do a lot of algebra here. Especially, the good thing was that it started at 0. So plugging it in this guy for 0 was really easy because it got rid of the e. But if it wasn't 0, if I said y of 1 equals 0.1, this would have been a completely different problem. And you might have some natural logs in there as well. So you want to be very sharp when it comes to your algebra. You can always just review a little bit of it, especially the exponentials and the logs. But in general, just hopefully you feel really comfortable with that.